this video, we are going to continue reviewing for the Module 3 test. On this problem, it's asking me for the vertical asymptotes of the graph. So my function is f of x equals x squared plus 5x minus 14 over x squared minus 2x minus 8. So I want to find the zeros of the denominator. So x squared minus 2x minus 8. What makes that equal to 0? So I'm going to have to factor here. So x and x. For x squared, the numbers that multiply to give me negative 8 and add to give me negative 2 would be a negative 4 and a positive 2. So there's the factors. Now I'll need to set these factors equal to 0 and solve them for x. So I will add 4 to both sides here. So I get x equals 4. And I'll subtract 2 from both sides here to get x equals negative 2. So those are the zeros of the denominator. Now remember, there is a disclaimer that your vertical asymptotes are the zeros of the denominator that are not also zeros of this numerator. So I need to make sure that 4 or negative 2, neither one are zeros of that numerator also. So I will factor it. So again, x and x for x squared. Numbers that multiply to give me negative 14 and add to give me positive 5 would be a positive 7 and negative 2. And when I set these equal to 0 and solve them for x, here I'll subtract the 7 from both sides to get x equals negative 7. And here I will add the 2 to both sides to get x equals 2. So that is the zeros of the numerator. So you'll notice that none of these are the same as the zeros of the numerator. So you have x equals 4 and x equals negative 2. Okay, remember, it's always x equals, so there are never y equals on vertical asymptotes. All right, on the next one, we're going to find the domain of the rational expression. We have f of x equals 2 over x squared minus 2x minus 35. So we need to make sure, since this is a rational expression, that our denominator does not equal 0. So x squared minus 2x minus 35 cannot equal 0. So I will put these in factors. X and x for x squared. Numbers that multiply to negative 35 and add to negative 2 are a negative 7 and positive 5. Neither one of these factors, when I set them equal to 0, can equal, that's what I want to leave out of my domain. So when I set those to not equal 0 and solve them for x, so in the first one I'll add the 7, so x equals 7, and on this one I will subtract the 5 to get x can't equal negative 5. So those are what I need to leave out of my domain. You'll notice that it wants your answer in interval notation. So what I like to do is draw out a number line that has all the numbers from negative infinity to positive infinity. And then I'm going to put my restrictions on that number line in the order that they come. So negative 5 would come first and then 7. Because now I can see the 3 intervals. negative infinity to negative 5, negative 5 to 7, and then 7 to infinity. So negative infinity to negative 5. In union with, that in union with symbol is in your math lab toolbox. Negative 5 to 7, in union with 7 to infinity. All right, on this next problem, it is looking for the horizontal asymptote. And remember, that is where you compare the degree of the numerator with the degree of the denominator. The degree is going to be the highest exponent. So the degree of the numerator is 3. The degree of the denominator is also 3. So when those degrees are equal, your horizontal asymptote is going to be at y equals, then you just make a fraction out of those leading coefficients. So I have 4 over 5. So y equals 4/5 is your horizontal asymptote. Right, on this next problem, we are going to find several different characteristics of rational functions. The first thing we're going to look for is the domain. So my function is f of x equals 5x plus 2 over x. So the domain of this function, I want to make sure that the denominator, which is just an x, does not equal 0, which means all the numbers on the number line except for 0. So negative infinity to 0, and then 0 to infinity. The next thing that you're going to look for is the x-intercept. The x-intercept comes from the zeros of the numerator. So I have 5x plus 2. Let's see what makes that equal 0 by solving it for x. So I will subtract 2 from both sides and get 5x equals negative 2, and then divide by 5. So x equals negative 2/5. Now, you'll notice when you type in this answer, it'll say type in an ordered pair because it is an intercept, which is a point. The x-coordinate will be negative 2/5, and the y-coordinate is 0. And then you're going to find the y-intercept. To find the y-intercept, you replace all of the x's in the function with zeros. So here's what I'm looking at. If I replace all of those with 0, I'll have 5 times 0 plus 2 over 0, which gives me 2 over 0. You cannot have a 0 as your denominator. That is undefined. What that tells me is there is no y-intercept. So those are 3 characteristics that we're looking at. The x-intercept is at negative 2/5, 0. There is no y-intercept. So let's looking at our graphs, you will notice that all of these graphs, those green dashed lines are the asymptotes. So even though it didn't ask me to find the vertical and horizontal asymptotes, those are going to be valuable characteristics to determine which graph this one is. So let's talk about where these are. Your vertical asymptotes are zeros of the denominator, which I already found. I already found that when I was looking at the domain. The 0 of the denominator is 0. So that's your your vertical asymptote. Now, your horizontal asymptote we're looking at the degrees. The degree of the numerator is 1, and the degree of the denominator is 1. When your degrees equal each other, your horizontal asymptote is just the leading coefficients, 5 over 1, in other words, at y equals 5. So looking at these characteristics, all right, this is the A option. So what I want to look for first is the correct asymptotes. So remember, our vertical asymptote was x equals 0, which I do see that. That's the x equals 0. Your horizontal asymptote would be at y equals 5. So if I'm at y equals 5, 2, 4, it should be right here. So that's why it can't be A. Let's look at B. Look at your vertical asymptote. Where should it be? The x equals 0 is actually a vertical asymptote on the y-axis. It should be on the y-axis, so it can't be B. Let's look at C. So vertical asymptote, x equals 0. Horizontal is in the right place at y equals 5. So now let's look at our other characteristics. Remember where your x-intercept was. It should be at -2/5. So here's my x-axis. -2/5 means that should be crossing the line at that point. And D. Vertical asymptote, x equals 0. Horizontal, y equals 5. X-intercept at -2/5. And then you'll notice the other characteristic was it doesn't have a y-intercept. And you'll notice that this graph will never cross the y-axis. So that's why it would be that D option. All right, this next problem is going to ask me all the things about the rational function. So the first thing I am going to do, because it helps me answer a lot of the questions, is see what the factors are and then see what the zeros are. So I am first of all going to write each of these in their factored form. So I'm factoring both of these trinomials. So up top in the numerator, I'll have x and x for x squared. To multiply to get -3 and add to get +2 would be a +3 and a -1. In the denominator, I'll do the same thing. X and x to get x squared. Factors of 6, so I've got to multiply to equal 6 and add to equal 5 would be +3 and +2. Now I'm going to write the zeros of the function. If x plus 3 is a 0, or is the factor, that means -3 is the 0. If x minus 1 is the factor, then +1 is a 0. In the bottom, x plus 3 is a factor. That means -3 is a 0, and so is -2. So, first question is, what is the domain? So we want to exclude the zeros of the denominator from the domain. So I like to look at my number line from negative infinity to positive infinity. Put my restrictions in the order that they come, so -3 comes before -2. And then I can see the 3 intervals. So the domain will be negative infinity to -3. In union with, the middle interval is -3 to -2. In union with, the last interval is -2 to positive infinity. Then the next group of questions is asking about the x and y intercepts. So remember what the x-intercepts are. They are zeros of the numerator that are not also zeros of the denominator. So -3 is not an x-intercept because it's a 0 in both places. So the only x-intercept is the 1. And remember, we're going to enter that as an ordered pair, 1, 0. The y-intercept you get from replacing all of the zeros in the function, all of the x's in the function with zeros. So if I do that, I would have 0 squared plus 2 times 0 minus 3 over 0 squared plus 5 times 0 plus 6. All of these would go away because they would end up being zeros. So I'll be left with -3 over 6, which reduces to 1/2, which means the y-intercept, its coordinates are 0 and -1/2. All right, the next part of the problem, let me go ahead and write what those factors were again. Which means the zeros were -3 and 1 up top, and -3 and -2 in the bottom. So the vertical asymptotes are zeros of the denominator that are, so the zeros of my denominator are -3 and -2, but that are not also zeros of the numerator, which means -3 is not a vertical asymptote, just x equals -2. Now, the horizontal asymptote comes from when we compare the degrees of the numerator and the denominator. Since both degrees are 2, that means the degrees equal, and you make a fraction out of the leading coefficient, which both happen to be 1s. So 1 over 1 is 1, so that is where your horizontal asymptote will be. All right, looking at the A graph, let's see if, first of all, the first thing we want to look at are the asymptotes. They should be at x equals -2. So here's my origin. X equals -2 is here. So that's where your vertical asymptote should be. So since it's not, it is not that one. Let's look at B. Vertical asymptote, x equals -2. Your horizontal asymptote would be at y equals 1, which means it should be up here where y equals +1. That horizontal is at y equals -1, so that's why it's not that one. Looking at C. Again, your vertical asymptote should be at x equals -2. So it is not that one. That one's at x equals +2. So let's look at D. Horizontal, vertical, x equals -2. Horizontal, y equals 1. It should be crossing the x-axis at 1, 0. So here is the x-intercept. It should be crossing the y-axis at 0 and -1/2. So there is your y-intercept. So that's why it would be the D answer. All right, last one for this video. Finding all the things again. This one, I don't need to factor because there's no factoring to do. If x minus 4 in the numerator is the factor, that means its 0 is positive 4. If x minus 5 in the x plus 5 in the denominator, that means its 0 would be -5. So those are the zeros of the numerator and the denominator. So the domain, which is our first question, we'd need to leave out that 0 in the denominator, which is -5. So I want to include everything from -infinity to -5, and then 5 to infinity. So -infinity to -5 in union with -5 to infinity. X-intercepts, the next part. Zeros of the numerator, which is 4, and that's not a 0 of the denominator, which means the x-intercept is at 4, 0. The y-intercept you get when you replace all of the x's in the function with zeros. So you'd have 0 minus 4 over 0 plus 5, which would give me -4/5. So your y-intercept is at 0 and -4/5. All right, the next part of this problem wants us to find the vertical and horizontal asymptotes. Again, none of ours are going to have the oblique. So vertical asymptotes are at zeros of the denominator, which is -5, that are not also zeros of the numerator, which the -5 is not. So your vertical asymptote will be at x equals -5, and your horizontal, since again both degrees are 1, so if I make a fraction out of their coefficients, I get 1 over 1, which means my horizontal asymptote is at y equals 1. So let's look at some of these graphs. All right, so here's the A graph. The vertical asymptote should be at x equals -5, which it is. Horizontal asymptote should be at y equals 1, which it is not. It's at -1. So it's not the A graph. Let's look at B. Vertical at x equals -5. So that's -2, that's -4. So here is -5, and it is not there either. So it's not that one. Let's look at C. Vertical, x equals -5. Horizontal, y equals 1. So it does have both of those. It crosses the x-axis at +4. And then it should cross the y-axis at -4/5, which is almost -1. So this one looks like it has all the correct characteristics. Let's look at this next one. Vertical asymptote, x equals -5. So there's -2, there's -4. So it should have a vertical asymptote right there. So that's why it's not the D one. It would be the C answer.